The trade-off between risk and return will be discussed in the concept of microeconomy and in the concept of utility and budget curves, if you remember. If you don't remember, I start with a very quick recap. That if you remember in the microeconomics, we discussed that we assume that we have two goods in the economy. We have good Y, for example, and good X. And the consumer will be rich to a certain amount of the utility between consuming X and Y. Since the amount of the utility is fixed, so that's why if you want to increase the amount of X, you have to decrease the amount of Y, and vice versa. And that shows that the utility curve has to have the negative relationship. Then at the other side, we say that this is our utility. It means that the amount that we desire, and each consumer, it has a lot of utility curves. But the consumer has a restriction as well. What is the restriction? Is our budget. Since our budget is a limited amount, so we have again two options. We can consume all from one product. For example, based on our maximum budget, we can consume this amount of Y. Based on, again, our maximum budget, if we spend on X, we can buy this amount of X, or we can be buying between these two. Such a bad drawing, let's say this one. Then we say that if we want to know that at which situation the consumer is getting the maximum utility, is the utility which is tangent to the budget curve. So this is the point that the consumer can have the maximum utility, this amount of X1 and this amount of Y1. So I want to bring exactly this risk and return in this area. So instead of having product X and product Y, now I want to have here risk, and I want to have here as a return, and I want to know that how much this risk and return is producing utility for the consumer. So, okay, let it be, then I clean it later. I start again with one example. In the example, I assume that an investor has a certain amount of wealth and he wants to invest. So he has two options for the investment. The first option is on risk-free asset, which is like treasury bills, right? So T-bills, we assume that are risk-free asset. And then the other one is to invest in the stock market. For the risk-free asset or treasury bills, since the amount of the risk is zero, so that's why the expected value will be equal to real value. So if we show it with RF, so it means that return on risk-free asset, and is exactly equal to actual value of the return. Expected value and actual value are the same. How about for the stock market? Of course, for the stock market, the risk is associated, so we have the risk. And that's why the amount of the expected value will be different than the amount of actual value. So let's say that we assume that the expected value that the investor is receiving on the stock market is shown with RM. So this is the expected value. This person has limited budget, right? So if we say that the person is investing B is the fraction of saving on a stock. So B is the fraction of saving that the investor is investing on a stock. So therefore, how much will be the fraction that he's spending on risk-free? Of course, once we are talking about fractions, so it means that 1 minus B is a fraction of investing on T-bills. So if we want to calculate the weighted average of expected value, why we say the weighted average? The weighted average only because of these two fractions. If I want to talk about the expected value, this here is already expected value. I said in the beginning that RF is the expected value of the risk-free, RM is the expected value of a stock market. Since we have defined them as the expected value, so do remember that here is expected value. Here is also again expected value. That value. So why we say weighted average? Because some fraction of our saving is coming to a stock market. Some fraction of the saving is going to T-bills. So that's why once we want to know that how much is the average of this return on assets, so we have to calculate the weighted average. So how much will be the weighted average? So the weighted average is, for example, B multiplied by the return on stock plus the fraction that we spend on treasury bills multiplied by the amount, the return on treasury bills. So once we have the combination of two different type of stock, so it means that we have a portfolio. So in another way, we are calculating the return on our portfolio. So this is the average weighted, the weighted average of expected value of portfolio. Then, do we have any risk associated with T-bills? Of course not. Do we have any risk associated with a stock market? Yes. For example, we show it with sigma M. So it means that it is risk of stock market. So do we have any risk associated with portfolio? Of course, yes. Why? Because once the portfolio consists of risk-free and risky asset, so definitely the concept of risk is available in the portfolio as well. So we show it with sigma P. And the formula is sigma P is equal to the percentage that we invest in a stock market, which is B, multiplied by the risk of stock market. So this is the risk of a portfolio. So now I want to prove this formula for you. Before proving the formula, I have to tell one more definition, and it is here. Since this is the risk-free asset, RF, expected value of the return, is equal to actual value of the return. But for the stock market, since we have the risk concept, the expected value is different than the actual value. So that's why I assume that the actual value is RM, and the actual value is the expected value. So this is actual value of return on what? On a stock market. So far so easy, right? Just I have defined some abbreviation, that's all.